A new dawn. Huawei's bold leap into EUV technology. Huawei is making a very big move. The Chinese technology giant is stepping into the world of extreme ultraviolet lithography. This development is truly significant for the global semiconductor industry. Huawei plans to start trial production of its EUV system soon. This is expected in the third quarter of 2025. Full mass production could then begin in 2026. This timeline is ambitious. It shows Huawei's determination. EUV technology is incredibly complex. It is needed to make the most advanced computer chips. For years, only a few companies have mastered parts of this technology. ASML, based in the Netherlands, is the main player. Huawei's entry could change this landscape. EUV lithography, the tiny giant of modern chips. To understand Huawei's news, we must first understand EUV lithography. Think of lithography as a very advanced printing press. But instead of printing words on paper, it prints tiny circuits on silicon wafers. These wafers become the brains of our electronic devices. These circuits are incredibly small. They are often thinner than a human hair. The smaller the circuits, the more powerful and efficient the chip can be. This is why chip makers always want to go smaller. EUV stands for Extreme Ultraviolet. This refers to the type of light used in this advanced printing process. EUV light has a very short wavelength. It is precisely 13.5 nanometers. This extremely short wavelength is the key. It allows chip makers to draw much finer patterns. These finer patterns create smaller transistors. Smaller transistors mean more can fit onto a single chip. This leads to faster smartphones, more powerful computers, and smarter artificial intelligence. It is the engine of modern electronics. Making chips with features smaller than 5 nanometers requires EUV technology. Older technology, like deep ultraviolet UV lithography, has its limits. LDP versus LPP, Huawei's smart alternative for EUV light. Huawei's approach to creating EUV light is interesting. They are using a technology called laser-induced discharge plasma, or LDP. This is different from the method used by ASML. ASML uses laser-produced plasma, or LPP. Both technologies aim to do the same thing. They both need to generate that crucial 13.5 nanometer wavelength EUV light. This light is essential for advanced chip making, but the way they create this light is not the same. Understanding this difference is key. How does Huawei's LDP system work? It starts by vaporizing a tiny droplet of tin. This tin is placed between two electrodes. Then, a high-voltage electrical discharge is passed through the tin vapor. This discharge converts the tin into a plasma. This plasma then emits the EUV light needed for lithography. Some experts believe this LDP method could have advantages. It is considered a simpler approach by some researchers. This simplicity could be very beneficial for Huawei. LDP might also be cheaper to build and operate. It could consume less energy. Despite being simpler, LDP is believed to be just as capable of creating the necessary EUV radiation. If Huawei masters this, it will be a significant achievement. China's tech independence, a strategic imperative. Huawei's EUV development is not just about technology. It is deeply connected to China's national strategy. For years, China has aimed for greater technological self-sufficiency. This is especially true in the critical semiconductor sector. The country currently relies heavily on foreign technology and suppliers. This reliance is seen as a vulnerability. Recent international events have highlighted this. Access to advanced chip-making tools has become a geopolitical issue. This makes domestic innovation very important. The United States has influenced export restrictions on advanced technology to China. The Netherlands, home to ASML, has also implemented rules. These rules prevent Chinese companies from buying ASML's most advanced EUV machines. This has created a major hurdle for China's chip ambitions. Without EUV tools, it is very difficult to produce the world's most powerful chips. Huawei's effort to build its own EUV system is a direct response. It is a way to bypass these sanctions. Achieving self-sufficiency in EUV technology would be a landmark moment for China. Section 5. Shifting Tides. Huawei challenges ASML's EUV dominance. ASML has long been the king of EUV lithography. The Dutch company holds a monopoly in providing these complex machines. These machines are essential for making chips at 5 nanometers and smaller. Chip giants like TSMC, Samsung, and Intel rely on ASML's EUV tools. Huawei's entry could change this dramatically. If Huawei commercializes its LDP-based EUV system, it would break ASML's monopoly. This would introduce competition into a market that has had none. Competition can lead to faster innovation and lower prices. The news of Huawei's progress has already caused ripples. On March 10, 2025, ASML's share price dropped by 7%. Huawei's news was a significant contributor. The potential for a new competitor is a serious consideration for ASML. The company has invested billions into its EUV technology. While Huawei is still in development, the threat is real. Section 6. The path to production. Huawei's EUV hurdles and hopes. Developing a working EUV system is one thing. Bringing it to mass production is another major challenge. Huawei faces several significant hurdles on this journey. One key challenge is achieving sufficient power output for the EUV light source. Early prototypes might operate at lower power levels, perhaps 50 to 100 watts. However, industry-standard EUV machines used in high-volume manufacturing typically require around 250 watts or more. Scaling up the power of their LDP source will be a critical test for Huawei. Another major hurdle is the manufacturing of high-precision optical components. EUV lithography uses a complex system of mirrors, not lenses, to direct the EUV light. These mirrors must be incredibly smooth and precise. Any imperfection can ruin the chip patterns. Developing the capability to produce these multi-layer reflective mirrors is extremely difficult. It requires specialized materials and manufacturing techniques. Huawei will need to master this aspect to ensure their machines are effective and reliable. Integrating all the complex subsystems into a reliable machine for mass production is also a huge task. An EUV scanner is not just a light source and mirrors. Section 7. China's chip ambitions and nation's coordinated push. Huawei's EUV project is not happening in isolation. It is part of a much larger coordinated effort by China. The country is determined to build a strong domestic semiconductor industry. Chinese chipmakers like SMIC, or Semiconductor Manufacturing International Corporation, have made progress. They have been producing chips using older DUV lithography. However, they are reaching the limits of what DUV can achieve, even with advanced techniques like multiple patterning. To move to smaller nodes, EUV is essential. The Chinese government is providing significant support for this ambition. This includes funding, policy incentives, and strategic guidance. Many companies are involved in this national push. For example, Naura Technology Group has been expanding its portfolio of semiconductor equipment. Naura aims to help build a comprehensive domestic supply chain. It has risen to become one of the top semiconductor equipment providers globally. Naura has also invested in other key companies like King Semi, further strengthening the ecosystem. This national strategy is driven by the need for technological independence. It is also driven by economic aspirations. A strong semiconductor industry can create high-value jobs. Section 8. The global tech game: new players, new rules. The potential success of Huawei's EUV technology could significantly alter the global tech game. It challenges long-held assumptions about technological leadership. For instance, Christophe Fouquet, the current CEO of ASML, had previously suggested that China's semiconductor industry was about 10 to 15 years behind the West. Huawei's rapid progress with its EUV system could prove this estimate to be too conservative. It shows that dedicated effort and investment can accelerate development timelines considerably. This is a wake-up call. Former ASML CEO Peter Wennink's earlier warnings now seem prescient. He had cautioned that imposing strict export restrictions on China would not halt its progress. Instead, he argued, it would motivate China to double down on its own research and development. This appears to be exactly what has happened. The restrictions may have inadvertently spurred the very innovation they sought to control. This highlights the complex and often unpredictable nature of technology competition and geopolitics. Actions can have unintended consequences. Section 9. Future chips: what Huawei's EUV means for tomorrow. Looking to the horizon, Huawei's EUV breakthrough holds immense significance for the future of chip manufacturing. If Huawei's system becomes commercially viable, China will join an exclusive club. It will become the only country outside of the Netherlands capable of producing these critical EUV lithography machines. This is a remarkable feat. It underscores the shifting global balance in high-technology sectors. It signals that the race for technological supremacy is far from over. New contenders can and will emerge. This development could spur increased global competition. Competition often drives innovation. It could lead to faster advancements in chip technology. It might also make advanced chips more accessible or affordable in the long run. However, it could also lead to a fragmentation of the global semiconductor industry. Different regions might develop their own technology ecosystems. This could create parallel standards or supply chains. The long-term effects of such fragmentation are still uncertain. It is a complex scenario with both opportunities and risks. It is also worth noting that other companies are exploring alternative technologies. For example, Canon in Japan is developing nano-imprint lithography, or NIL. While NIL is not directly targeting EUV's current applications, it represents another path for future chipmaking.